am Jonathan Badger, and I'm a computational biologist at the J. Craig Venter Institute. And I just want to talk to you about a gem that I've created for manipulating and displaying evolutionary trees in a standard format, which is called Newick. And I realize, most of you probably aren't biologists, but it could still be useful because it's also the idea of these trees are used, for instance, in the pharmaceutical industry for making vaccines. People need to know how the viruses are related. So, you may end up actually running into a case where, you might have had to implement something like this, and you can just use the gem. So what is a Newick tree? So a Newick is basically a way to express an evolutionary tree in a sort of a nested parentheses list. And on top here is a evolutionary tree that I created actually using the COX-1 gene, and it just has a bunch of mammals. And what you notice is down below are two representations of this tree. The first representation, can I actually point out, is it has no additional information like links or the links or the support values. It's sort of the simplest way that just has the branching pattern. But in practice, there's really two parts of additional information that you want. You want to have the length, which is how long these branches are, which is the amount of evolutionary distance between these things. And also you want to know, based on your criteria, how well supported are these nodes. And traditionally they're used in a statistical method called bootstrap replicates. In this particular case, the human-chimp grouping is very well supported, as is the cat-dog grouping, and this whole grouping of the carnivores with the ungulates. But if you notice, for instance, the cow and the whale relationship, which is actually a real relationship, by the way, is not particularly well supported. It's only about 53%, and that's also a useful thing. And by the way, this rendering of the tree was actually again created by the gem from this down below. So what does this gem give you? So it gives you routines for comparing trees. One of the things is a lot of times when you want to create trees of many different genes, you want to know, is this the same tree, ignoring things like distances, just the branching pattern, is this the same tree, is this a different tree? And because of various stochastic reasons, you won't get literally the same text string. For instance, order within branches isn't really meaningful. So, for instance, in this particular example, those two trees are in fact the same tree. No matter the fact that the human and the chimp are in a different order and the subtrees are in a different order, but they're representing the same relationship. And so I've got routines that basically say, is this the same tree? In fact, I also have routines that actually say, how far apart are two trees? If you've got a tree with 100 sequences, maybe only one off isn't that bad. Again, it makes these nice renderings of the trees that you can use in papers and in websites and so forth. You can extract subtrees. If you've got a really large tree, you may only be interested in one branch. You can reroute, which I'll show an example of. You can convert to a distance matrix, which is another thing I'll show you. And I've made it all very nicely object-based. It's got all the sort of standard things like 2S that you'd expect a Ruby class should do, so it acts like a good Ruby citizen. So the idea of rerouting is a lot of times you want to say, what is the most distant organism in your tree? And a lot of these times the programs don't actually do this for you. You have to actually specify. This is sort of ridiculous, but if your theory is pigs are extremely different than all other mammals, and you could take this tree and you could root it on pig. Again, you can make this distance matrix. This is not just taking the links off the branches. It's actually saying, what is the distance from human to chimp? In this case, it would be going out here plus the distance here. Or if you want to go chimp the cat, it would have to do this distance plus this distance plus this distance plus this distance. And it's just sort of nice that you can produce a nice distance matrix, and in certain programs actually take this as input. And so what's the point of this? So one thing is I created a system that makes evolutionary trees automatically from a genome or a metagenome, and I use it internally for that. I've also made some wrappers around some evolutionary tree drawing programs or inferring programs such as PALP and PHYLIP. I mean, this is important because everyone seems to have a different input and output, and it's kind of nice to have wrappers so that you can compare them easily. And the reason why I made it a gem was there was actually somebody who was using my programs in Ohio State that said, hey, this was a neat class, why don't you make it a gem? I'd like to use it. So maybe stuff from their lab will be coming out. And again, it's in GitHub under JH Badger, and it's also in Ruby gems as Newick-Ruby. Cool. Yeah.
I'm just wondering about the tree drawing, if you used a graphing library to do that.
Yeah, so I ended up actually using FPDF. I was also thinking about maybe also adding, I don't know, maybe SVG support now that SVG is also becoming fairly popular.
So I'm not very familiar with this space, and I was wondering, is the data open as well? Are there places?
Oh yeah, yeah. So I mean, obviously there's a large database of sequences called GenBank, and normally you have to then use an alignment program, and they're open source alignment programs to basically align all the regions, and then you use a program to infer the tree. An open source version is PHYLIP. And sort of PHYLIP and PALP are kind of the two major programs. PALP, unfortunately, is still closed source, so PHYLIP is the free one.
Cool, thanks.
Since all the data and tools are already open source, is any of this output available just like a website? Like if you have a URL and you spit in like a gene identifier, and have it, pop out one of these trees. Is that available, or is that an idea?
I haven't done it, but like you said, like have a website that would have, like, say, run PHYLIP behind the scenes. You give it data, and it would spit out. Yeah, that could be useful to have like a server to do that. Yeah.
This is a really neat project, and I was wondering what was the hardest part of doing that in Ruby.
I would say I had to write a little parser that would handle this because there's actually, I mean, it's essentially, I guess, almost like a YAC parser in the sense that because there's identifiers, and you have to make sure that you don't confuse, like a colon can be in the middle of identifier, but it also is a distance. You have to sort of figure out sort of the general way of parsing. I mean, I guess if you've written a parser for like a programming language or anything, it's maybe not that hard, but I guess it was hard because it was the first time I'd sort of done that sort of thing.
Have you considered using Treetop?
What's
a Parser Generator?
Oh, no, that would probably, maybe if I had done it from the beginning, maybe that would be the way to actually do a Parser Generator. I sort of hand-coded the parser.
Very cool. And way over my head.